Hello guys, welcome to my channel. Today in this video I'll be proving a theorem which is order of every element of a finite group divides order of a group. So let's prove it. First we are given that G is a finite group, and let's suppose the order of G is M. So now let us consider an element of a group G and order of A. Let's suppose it to be N. So here we have to prove that order of an element divides order of a group, which means we have to prove that n divides m. So let's consider a subset. Since the order of A is n, we can write it as a to the power n equal to e. So here let's consider a subset of the group containing elements e, a square up to a n minus 1. So here why we have taken n minus 1, such that since order of a is n, so if we take a to the power n, it will become the identity element itself. So this is a subset of G. So here we have to prove H is a subgroup of G. So for this we have to prove the closure property. So let us take two elements, a to the power a and a to the power j of H, and here both I and j are greater or equal to 1 and less than m. Less than n. So if we take the operation, we will get a I plus j. So here we will have to use division algorithm. So by division algorithm, we'll get that I plus j will be, so here we will get by division algorithm I plus j equal to n into some integer plus r, and here r is less than or equal to 0, greater than or equal to 0, or less than n. So if we take this for now, we can write in the place of I plus j n q plus r. So n q plus r, we can use the exponential property, n q into e to the power r. We are left with this, since we know that since the order of A is n, so we can write it as a to the power n will be equal to identity. And if we take the part of identity element, it will be identity itself. So we are left with a to the power r. Since the power of a to the power r, since r is greater than or equal to 0 and less than n, so it belongs to H. So we have proven, therefore H is a subgroup of G. So since F is a H is a subgroup, we can use Lagrange's theorem. The Lagrange's theorem states that the order of a subgroup divides the order of a group. So here we can see that the order of a subgroup is n and the order of a group is m. So we are left with n divides m. That is the proof.